Hello, good afternoon dear friends. Myself Sonigra, and today we are going to discuss about the solution of GTU examination question paper in the subject of mechanical drafting. The question paper is taken from the exam December 2013, and previously we solved few questions of the same question paper, question number 1 and 2, and today we will continue with some more examples of the same question paper. The first question in the question paper is a pictorial view of an object is shown in the figure, and we have to draw three views: sectional front view, top view and sectional left hand side view that we drawn last time like this. These are the three views of that problem. Then second problem which we solved last time is this one, and this is the solution for second A, asked for 7 marks. Then question number 2A in option, hexagonal pyramid, and this is the solution of that hexagonal pyramid sectional view. Now question number 2B, which is asked for 7 marks. The question is given as draw the symbols for the following: the first, fillet, square butt weld, single U butt weld, pipe joint, pipe elbow 90 degree, reducer and a T joint. So first, that is fillet. Now what is fillet and where it is used? The fillet is a joint which is used in the welding, and its symbol is drawn like this: a right angle triangle. You can draw any shape, but the shape should be right angle triangle with any dimensions in the answer sheet. Just you draw right angle triangle, you will be given 1 mark for that symbol. Then second one is square butt weld, which is used in welding. The symbol is drawn like this: just two vertical simple lines parallel to each other at equidistance. That is the symbol of square butt weld. Then number 3 is a single U butt weld, and the symbol for single U butt weld is drawn like this: a U shape as shown over here, U, and a small line below U of any dimension. Whenever you draw the symbol in the answer sheet, it's not necessary to maintain some dimension, but it should be clearly visible to the examiner. It is clearly drawn like this, and write the name of symbol over here. Suppose number 3 is single U butt weld, answer number 2B. Everything should be written on the pages, because students forget to write the question number on the answer sheet. So you should take care about that thing, that question number should be written on every page or above the drawing which is drawn in the drawing sheet. The next is pipe joint, and the symbol for pipe joint is this one: a straight horizontal line and 2 small days or 1 small days. Why 2 small days? 2 small days shows it's a flange joint, and 1 days shows it's a screwed joint. If it's a flanged joint, 2 days should be there, and it's a screw joint, 1 day should be there. So you can draw either of these two. Not needed to draw both these symbols. Any one symbol you can draw, but yes, if it is asked that draw pipe joint for flanged connection, then you have to draw this one. And if it is asked that draw pipe joint for screwed connection, you have to draw this symbol. Then symbol number 5, that is pipe elbow 90 degree. So it is drawn like this. 90 degree elbow is there, which is used to connect two pipes which are at an angle of 90 degree to each other. It is shown like this. Here this is an elbow, this is the pipe of extension, and this is the pipe of extension. So 1 and 2, these two pipes are joined with the 90 degree elbow as shown here, and 2 lines here are drawn. It means that it's a flanged coupled, or it's a flanged joint. And here if it is asked that draw pipe elbow 90 degree for screwed connection, in case of screwed connection you show single lines over here, 1 line over here, 1 line over here. So these lines represents the connection point. Then number 6 one that is reducer. Reducer is drawn like this. Reducer means it reduces the diameter of pipe from certain amount to certain amount. It may reduce from 5 mm, from 10 mm to 5 mm, or 25 mm to 20, or 50 to 25. That depends upon the size of the pipe. And this is another symbol for the reducer. Here also two symbols are drawn. The first symbol which is drawn here, it is used for flanged coupled, and the second symbol with one line segment is used for screwed connection. So if it's a screwed connection, this symbol is to be used. Then number 7th one, that is T joint. So T joint is drawn as the name indicate by the letter T, drawn in reverse. It's a flanged connection, so double daces are there at 3 points, and it's a T joint with a screwed connection, so one dash at every connection. So it's a T joint with screwed joint. Then question number 3A. A vertical square prism, vertical cylinder of diameter 75 mm and 115 mm height is penetrated by another cylinder of 60 mm diameter and 100 mm axis long. Here two cylinders are given, vertical cylinder and horizontal cylinder. Dimensions of both the cylinders are given to us, and the two axes bisecting each other at right angle. The axis of both these cylinders bisect each other at right angles. It is given data. Draw the front view showing curves of intersection for this case. So for that, this is the isometric drawing of given case. Vertical cylinder having diameter 75 mm and 150 mm, 115 mm height, and it is penetrated by another cylinder diameter 60 mm as shown here with red color. So this cylinder penetrates this vertical cylinder. So how to draw this curve of intersection? So let we have hands-on exercise for this case. First, the diameter of cylinder is given 75 mm, vertical cylinder. So take 75 mm as a diameter, or 32.5 mm as a radius, and draw a circle. It will be like this. Circle having diameter 75 mm. So this is the circle having diameter 75 mm, and here draw XY line which represents the intersection of horizontal plane and vertical plane, like this. This is XY line, and height of the cylinder is given to us, that is 15 mm. So from this center line draw axis, and on this axis you can mark the height of cylinder, which is given as 115 mm somewhere here. So from this point to this point height is 115 mm, and from that point draw a line to show upper edge of the cylinder, and here draw a rectangle having height is equal to 115 mm and width is equal to 75 mm, like this. So these are the two views of given cylinder, and draw its third view. Its third view also will have the identical shape as the front view, that is height is equal to 115 mm and width is equal to 75 mm, and here the axis would be there of that cylinder inside view. This is the axis of cylinder inside view. You can draw here meter line. Meter line means line drawn at an angle of 45 degree to the side of top view to take projection from its top view and projections in side view, like this. You can draw line from here to take projection and from here to take projections. and so on. So these are the views for vertical cylinder having given dimension. And here this cylinder is penetrated by another cylinder, and the diameter of that cylinder is also given to us, that is 60 millimeter. So take 30 millimeter as a radius on compass and draw a circle over here of diameter 30 millimeter at the middle of the axis in side view. This is the cylinder, which is penetrating cylinder, as red cylinder shown in the isometric view. Here it bisects the axis, hence the center of the cylinder would be at a height of middle of its total height of given cylinder. Means height of cylinder is given 115 millimeter, so at the middle 115 by 2, that is 57.5 millimeter would be the height of this axis from XY line. So after drawing this axis of this horizontal cylinder, we can draw its side view by taking projection from this end. Take projection from here and here. This is this line. Similarly line from this end, from this point, draw a line, take projection over here. So from here to here another line is there, and the length of that cylinder is not given to, is given, that is 100 millimeter. So from this axis 50 millimeter on this side and 50 millimeter on this side, mark a point, and from that draw a vertical line. So this cylinder length is 100 millimeter, 50 millimeter on either sides. Similarly in top view we can draw the same cylinder, and top view and the front view of this horizontal cylinder would be alike. Both will be same, having rectangle width is equal to 100 millimeter and height is equal to 60 millimeter, that is diameter of that penetrating cylinder. And this is the axis of that cylinder, that is horizontal cylinder, or say penetrating cylinder. So this is the case which we have drawn. Now we have to find out the curve of intersection, which is over here. How to locate that curve of intersection? So for that, it's a usual practice to divide this side view into equal number of parts. In side view, circle is there of that cylinder, so divide that circle into equal number of parts. So let me divide into 8 equal parts. So lines at an angle of 45 degree to each other drawn over here. We divide the circle into 8 equal parts like this. So you can name the points. So somewhere here, this is point number 1. So this is point number 2, 3, 4, 5, 6, 7 and 8. 8 points are there over the periphery of that horizontal cylinder. And all these 8 points to be transferred to its front view over here. Here is 1 dash, 2, 3, 2 and 4 would be on the same horizontal line. So that can be transferred like this. From these 2 points, draw horizontal line as shown over here like this. So here point number 2 dash is there. Similarly 3 point would be somewhere here. Point number 4 dash here. 5 is here. So 5 dash is here. 6 is here. So from 6 and 8 draw a straight horizontal line, or say projection line, and this projection line can be shown by light lines as mentioned here. And here is point number 6 dash, here is 7 dash, and here is point number 8 dash. So that is the front view of all these peripheral points over the cylinder. Similarly these points can be transferred to its top view by taking projections from side view like this. Draw vertical lines from all these points, transfer to meter line, or say metre line, and these vertical lines will cut this meter line at some point. From that draw horizontal line. Here also transfer those points over here. So here is point number, this point, this is point number 1. So point number 1 would be here, and here is point number 1 is here, point number 2 is here, point number 3 is somewhere here, over here. Intersection of this line and this line is point number 3. From 4, draw vertical line from point 4 and horizontal line from point 4. So it is shown over here like this, and this horizontal line will cut this vertical line at point number 4. Then from point 5, draw vertical line. It will cut the meter line somewhere here and horizontal line from this point. So here is point number 5. So 1, 2, 3, 4, 5. Similarly, point number 6 would be here. Point number 7 and point number 8. So after locating all these 8 points in top view, front view and side view, let me find out the point of intersection between this horizontal cylinder and vertical cylinder. So for that, let me pick up point number 1. Point number 1 is here. So draw vertical line from point 1, this line. It will cut this vertical cylinder at one point, somewhere here. Intersection of this point. Intersection vertical line from point 1 over here. It will cut the circle at this point. So name this point as point number P1. Similarly, 2 point is here. So point number P2 would be here. Point number P3, that is here. Point number P4, 5. So here point number P5 would be there. Then P6, P7 and P8. Name all these points P1 to P8. Now from point P1, draw straight vertical line as shown here. From P1, straight vertical line and 1 horizontal line from point 1. So intersection of these two lines, vertical line from point 1 and horizontal line from point 1. Here is point number P1 or P1 dash, as it's a front view, dash should be inserted. So that is point number P1. Now to locate the position of point number P2 from point 2, here is point number 2. From point 2, draw straight vertical line like this, and that will cut horizontal line from point 2 at one point. This is point number P2 dash, and from point 3, horizontal line from point 3, and here vertical line from point P3. This is P3 dash. Similarly, P4 would be here, both at P2 dash. For point number 5, from 5 draw horizontal line, and from P5 draw vertical